Welcome back. In the first two videos, we were very keen on learning basic Python and training your first simpler model. In this video, we will train another powerful simpler model, but also visit the basic machine learning concept and map them to the code which we have learned in the past videos and also learn some new concepts as well. A simple machine learning problem always has some basic concepts. Let us look about what are these steps. We always start with data. Then comes the model. And based on this model, we are going to make certain predictions. This is where we are using the model. We can almost universally project any machine learning problem in these three steps. There are further sub-steps in this, each of these three things which you are looking into. For example, data will tell us what is the type of problem it is. We have looked into a linear regression problem in the last lecture. So at a high level, there are kind of like regression problems. Then there are classification problems. Regression is where we are predicting continuous values, some VC, like we looked into last lecture, a line which we were learning, but indirectly it was predicting a continuous value. This can be, for example, housing prices, stock prices, what is the price of Tesla stock. Like you can see, there are endless kind of options here where we want to predict continuous values. Classification are where, say, out of some categories, we want to predict within those discrete categories, like digit classification, given an image, what is this digit, identifying objects in the scene, there are some, say, fixed set of objects, or identifying, say, is it a cat or a dog from image, or identifying if this email is a spam or no spam. So there are so many of these examples. Data will tell us what is the type of problem. From the model side, we again have choices. We can either go for simple classical models. This is old machine learning. Or we can go for neural networks, the most recent models. Finally, when we do prediction using the model, we will have some concept of error or accuracy, that how good or bad the model is. We start with data, model, and prediction. In each of these steps, the data identifies the problem. Here we are talking about these set of problems, and we will advance into further more complex set, but it can be regression or classification. From the modeling side, we have different kind of options available, classical models, neural networks. From the prediction side, we again have access to error accuracy metrics. Any machine learning project will go kind of in this direction, and we will reiterate over these things. Again, looking at the data, model, and prediction step. Now, if we map this to the code which we have been looking in Python, in the code side, we need some form to represent these three steps. And the libraries which we have introduced, they help us to do it. The data we often use to load using pandas, NumPy. In our lectures, we have looked at the NumPy where it defines kind of construct for us to play with numbers. We also used to use open source data from scikit-learn. In the model side, we used to use scikit to define a linear regression model for us, but it can define more complex models as well. Some decision trees, random forests. Then there are more complex libraries such as TensorFlow to help us define neural networks, such as even as complex as GPT networks, which are currently used by many language tasks. From the prediction side, we kind of use model.say predict functions from libraries to help us to forward pass on the neural network or to get prediction from one of these. In these three things, we have looked at NumPy, we have looked at scikit-learn, and we have looked at some sample code to predict model. Now, these three things can change based on the type of problem, but overall, the fundamental understanding still stays the same. For example, if we try to map our past lecture here easily, we were defining the data for X and Y, which was defined to represent a regression problem. From this regression problem, we were able to define a classifier, linear regression classifier. This classifier was trained. So training of the model is integral part of many of these libraries, and we were calling the fit function from scikit-learn to do it. And during prediction, we were calling the predict function to get the future predictions. In all of these three, the understanding data is one of the very core component. For that, we also looked into Matplotlib library to help us plot the data, that what are we visually trying to do. Next, we will understand all these three concepts through another simple example in the code. Next, we are going to look at k nearest neighbors classifier. This is a very simple classifier, and let us see how this works. For example, when a new test point T1 comes, it tries to find what are the nearest samples to this test point. And looking at the nearest samples, it will decide what this T1 is. For example, this T1 is a new image of a digit. And now looking at the digit T, it will be able to answer whether this D is, say, 1, 2, 3, or so on. How it will answer that? It will look at all the nearest samples. If most of them are, say, 1, it is going to say that this new T is also 1. So it's very simple. It looks at the nearest neighbors. For example, in this visualization, all this nearest neighbor will map to one class. This yellow maps to another, and so on. This visualization is actually created from a real digit dataset, which have digits from 0 to 9. These digits are images. So when a new image comes as input to the classifier, it looks at what are the nearest other images look like, and it tells us whether this image is 0 or 9. So it's a very simple classifier. And that's hence the name k nearest neighbor. Let us code this using a simpler notebook. Now let us look at the same classifier through a very simple Python code. I will share this Colab notebook link in the comment section so you can follow along. We will again use sklearn library. In this library, there are many different datasets. We are going to load digits dataset. Let us load the digit dataset. Before doing that, let me restart the runtime so it will clear out the current run of the notebook. Again, you can run this cell using Shift-Enter. This is the cell which you see here are two types, the text cell and the coding cell. The text cell is what you will also see when you will open this link. This cell is just to explain what is the digit dataset. We are not going to run these cells. Digit dataset is 8 by 8 pixel images. It's a very simple low resolution images. And each value in this one varies between 0 to 16 between, say, black and white. These are black and white images. We can visualize how this dataset looked like using Matplotlib, the PLT. I'm visualizing 3 digits. For loop is written in Python using for I in range 3. plt.imshow is the function which is used to plot images. And digits.image I is the way to get the first, second, third image in it. We are showing it on a grayscale. We can also give the title to this plot, like the title is what exactly this digit is, the target values from the digit loading class itself. We are also turning off the axis here. That's not important, and we are showing the plot. If you run this, we'll see the first 3 digits. The first digit is 0. It's actually looks like 0. This is low dimensional, so like you can see individual pixel here. This is 8 by 8 image. 1, 2, 3, 4, 5, 6, 7, 8 on one side and 8 on the other side. And depending what is the value of this pixel, we are visualizing it here. Similarly, the second is digit 1 and the third is digit 2. Now these digits are input images. We want to train a classifier which can automatically take this as input and say us whether it's digit 1, digit 2, digit 3, digit 0, and so on. The X and Y, which we have been currently playing with the data, X is the input to the model, which is the data which we want to give. These are the images. Y is the target which we want the model to learn. If you look at the first element output of the X, first element is actually an image where it's 8 by 8, so 64. And you see here some of them have values. So these are the things where we see the values in 0 as well. This thing highlight what is the grayscale values for each of the pixel. The maximum value can be 16 and the minimum can be 0. And these are also explained in the notebook in the first cell where it says that 0 is white and 16 is completely black. So in this one, these all are kind of close to 16, 15, and these white values are where we see these are close to 0. And the first digit, these are close to 0, some of the white values, and the sum of complete black values are also shown here, kind of close to 14, 15. We can see the size of the data as well. Size of the data is around 1797 total training input samples, each with 64 size, 8 by 8 images, and there are 1797 targets. The model needs to learn this from the targets or the Y value. Since this is the first time we'll introduce train test split. Whenever we train a model in machine learning, a part of the data is used for train and another part is used for testing purposes. So we want to see what the model does on the data which it has not seen. This is a very core concept and we will learn this deeper as we grow further. Currently, we are going to do train test split using sklearn model selection function. We want to give it X and Y as input and what is the size of test data we want to select. Here I'm saying that 0.2, it means that 20% of the data is going to be selected as test data. And you can also fix the random state. Random state means that every time you run this function, it will always create the same split. It will randomly select 20%, but if it's a different random state, that random selection may change. We fix this random state so that you also are able to replicate exactly same results, which I will do here. If you don't fix this random state every time you run the notebook, the results may slightly differ because the random selection may change on each run. We have X train and Y train and X test and Y test. Since 20% is roughly in the test, if you see what is the input size, and this shape is the way we remember this X and Y are numpy arrays now whenever you play with scikit-learn, as we looked at last 2 videos. Shape is kind of telling us that what is the input shape for X and Y. It has 1400 elements now in X, and the test has around 360 elements because 20% has gone to test. We are plotting, we are only printing the shape of X. Y will have similarly 1436, 37 as well. For example, we copy this cell, Control C, Control V, and instead of X, we can put here Y. Let us see what is Y train and Y test. Y train and Y test has 1437 again, but it's a single vector of digit itself, 0, 1, 2, 3, 4. So it doesn't have that extra shape dimension here, which is coming here because these are images. Let us create k-nearest neighbor classifier. It's very easy to create it. So you can directly use the scikit-learn, sklearn.neighbors, KNN classifier. KNN model can be defined using KNN classifier. You can give it how many neighbors to look at closely. If you don't give this neighbors parameter, like if you hover over it, it will explain you what it's going to do. By default, it's going to kind of select 5 as neighbors. I've also given it as 5 as neighbors, but you can play with this parameter as well. You can adjust the value of these neighbors as you want. After we define the classifier, we have to fit it. And this fitting is happening on the training data like you see here. Training data is the data which model will use to learn that model or its internal decision boundaries. This is the data which model have access to. We want to see how it does on the test data. What is the magic on the test? Again, train test split is very core to machine learning, and we will discuss this further as we grow. These are very simple basic concepts in this lecture. How does Y predictions look like? So Y predictions are again digits like you see here. These are the digits which we predicted for the test. How accurate they are. So accuracy, again, we are measuring using whether Y test and Y prediction match. Since this is something which is done again and again, scikit-learn has provided as a metrics class to do accuracy score. You run it and it will tell us what is the accuracy of our prediction. It's around 97.5% accurate. This varies from 0 to 1. 1 means 100% accurate. So our accuracy here is around 97.5% accurate. This is for a simpler classifier, this is very good actually. So our classifier is extremely excellent, even though it's very simple. So often in machine learning, you don't have to have very complex models. Depending on the data set, sometimes the simpler model may be very good. We can visualize what this model is doing. I'm going to go for a number of samples, 3 samples. You can change these values in visualization. We are again using Matplotlib. Like you see, Matplotlib is a very powerful tool, which we have been learning in the first 2 lectures. We are using IMShow to show the test data. And since it's a 64, remember, we are reshaping it 8 by 8 on the grayscale. And we are also seeing how the true and predictions look like. This is the true value and what the model predicted. So the true value of first image is 2. You can see it's created 2 shape. And we are also predicting 2. So model is learning very accurately. The true value here is actually 8, like you see here. The model is also predicting 8, like it's kind of little noisy. So model has learned to handle these things. True value is again 2, model is predicting 2. This is one of those examples where data set is not that easier, it's images, but still simpler, and a simpler classifier is doing amazing. You can play with this notebook at your own pace, and I'll see you soon in another video introducing more deeper concepts.